This is a Pasco wireless smart cart, and it's excellent on one of these tracks to record how it moves along. It's got sensors in it to record the motion. On top of this, we've put a launcher. This is a ballistic cart launcher, and it's got a little ball, and what we can do is we can put the ball in here, push it down against a spring, and it's locked. Now, when I put a timer release on this, so let's hold it, and I'll put it near a ruler so we've got an idea of how high it's going to go, and I fire it, 3, 2, 1, it goes up and it goes down. But what would happen with this cart if it's moving along? Will the ball go up and down and the cart will go on, or will it go up in a sort of curve and come down and land in the catcher? Let's see what happens. So I'm going to set this to fire, we'll load the ball, and we'll have a go. 3, 2, 1, go. Now we've recorded the video of the ball flying through the air, what we now need to do is import that video and analyze it. So let's open up the movie file and bring it in. And what we're going to do is we're going to just, I think I need run 1. And the first thing I need to do is the reason for the stick was that it's exactly 1 meter long and it can record the height. So let's put that into this video. So I'm just going to move this pointer so that it's actually right at the top and right at the bottom. It's going to go onto that line there. So we've now got exactly 1 meter. I'm going to play this then. We'll have a look. The ball's going up. You can see it just went over 1 meter before it was caught. Let's rewind this back to the start. And I want to move along just a few frames until really the ball is just about to come out. And there it's about to come out. So what I'm going to try now with this is to capture something on here. And we're going to use this little clever little tool, which is going to track the ball as it goes along. And the reason for using the green screen behind was so this yellow ball really stands out and we can capture it easily. So let's now start the auto capturing, and it will play the film through, and we recorded this in high speed, so it's much slower when we watch it return and play it back, and we can plot how this ball's going. You can see that it started off moving quite quickly, and as it's reaching the top it gets slower and slower and slower until it reaches an absolute dead stop going up vertically before it starts coming down and going along. Now, I've already done this, so I'm just going to stop this one and I'm going to go into one that I've prepared earlier. So let's say done then, and I'm going to go and have a look at what I've already recorded. So this now, if I run it, we will see that the ball gets fired, and I've put some vectors on there so that you can see how the ball was moving. there are two vectors. There's an orange vector, which represents the up and down, and there's a magenta one, which represents the X, the movement across. If we rewind it and run it again, if you watch the arrows, you'll see the orange arrow starts big, gets smaller until it reaches the top. We've got the magenta arrow, which represents the X movement, and that is basically staying the same velocity all the time. And the green one represents the direction of travel. And we can see it gets smaller, reaches the top, and then comes down again. And we can also see on the other side that I've actually drawn the graph of this. So it's plotted this graph at the top. Now, what I'm going to do with this, I've just rubber banded an area, and I'm going to suggest it's probably a quadratic graph. And in fact, it does seem to fit quite nicely as a quadratic graph of a here t squared plus some value of t plus c. So we've got this quadratic graph. On the bottom, I've plotted another graph, and this plots the x-axis. Now this should be the same all the way through. In fact, it does seem to vary very, very slightly between about 0.12 and about 0.14 and a bit as it's going along. So we've got a tiny little bit of kink in that. The other graph, that one is the x-axis. The other one, which starts off, is the orange one, which is the up, and that's got a constant velocity. At this point here, it crosses the 0 and goes down. So it's got the up direction for velocity and the down. And if you know your velocity time graphs, you'll know that they are going in opposite directions. So although it looks a nice straight line graph here, the first bit up to 0 represents the going up, and the second one is the going down. So if we replay this, we can watch it all in action again, and we can see the arrows drawing the graphs, and you can see how it behaves. So what we've got is two independent actions. I've got the cart moving along, and that's moving at a constant velocity. The ball is going up and down, and we've seen that's exactly what it does from the side. But when both are put together, the ball takes on this quadratic ballistic graph shape as both of the vectors are combined. So that's why when the ball goes up, it will go back down into this cart, and it will just catch it again, because basically the ball just feels like it's gone up and down, because that vector is independent of this vector, the one moving along. If you like this video and you'd like to see some more, then you can always click on the subscribe button and ring the bell to see when new ones come along. I'll see you in the next one. Bye bye.